Okay, yeah, it's okay. I'll pass out some later on. Those online, can you hear me? Is it too soft? Alright, we just wait a while more, okay? Alright, those who are here, who does not have the worksheets, then pass down your roll. Hey, we just do a quick. I already did the worksheet. No, you're not supposed to do the worksheet actually, because we're gonna do it in class. Yeah. But depending on the time, let's see if we can finish. Okay, I'm not sure. Okay, so those online, you guys just download the worksheet accordingly. Right, I've already sent a PDF earlier on. If you have done it good, you just check your answers, okay? So from there, all right, those who are here physically, all right, I'm just gonna quickly introduce myself, right? The quick introduction. Are you guys, any of you are overmarked students? No. Oh, one, two. Only two. Okay. So for those who are not overmarked students, okay, just a quick introduction, right? I'm Miss Stephanie and I teach secondary school sciences. All right. And then you can take a look here, right? All the branches, you can take a look which one is nearest to you or your school in case you want to continue with us next time, right? Let me record before I forget. Oh, already recording. Okay, so here are just the results. You can just take a quick scan. I'm not gonna read it out because it's cringe. Anyway, the PDF, all of you have the physical worksheet, so you won't need this, right? Then we'll start with the lesson proper. Okay? None of you did the worksheets yet, right? Did it already. Okay, then we'll just check the answers later. Okay? Alright. So let's look at, come in. That one science, right? Quick, take a seat. Do you have your worksheets? Do you have the worksheet? Come, just take a seat in front and then take one worksheet. All right. Okay. Let me share to the online students first. Nice. All right. So we're looking at classification of matter, right? Very simple, just solid, liquid, and gas. This one you learned in primary school before, right? Nothing new, correct? Okay, then we look at materials, right? So usually for the materials, what you want to take note of is the properties, okay? Physical properties, right? Things like melting boiling point, strength, hardness. So the first row, you need to know the definition. Okay, strength means it can withstand heavy loads without breaking or tearing. This is very strong. Versus hardness. So students tend to confuse these two together, right? So what's the difference between strength and hardness? Is that hardness is whether you can withstand scratches specifically. Okay, withstand scratches. So if you can scratch another material, you are very hard, right? So a lot of the drills that they use in industrial places to cut things like glass, etc., they will put diamond because diamond is very, very, very hard. Okay, it can scratch other materials. Flexible, you should know what it means, right? You can bend without breaking, essentially. The last one, elasticity, return to its original size. After you stretch, you bend or whatever, compress, etc. Okay, then you have more. This one like quite self-explanatory. Heat versus thermal or electrical conductivity. Right, melting boiling point mentioned. Density, do you guys remember the formula for density? Mass over volume. How to remember? Remember it as like a broken heart. M over V. Can you guys see? I zoom in a bit. M over V, like a broken heart. Okay, that's density's formula. All right, so those are the physical properties a substance or material can have. Okay, now we look at quantities. The most important thing about quantities is you must know the SI unit, the standard unit that is used universally. Okay, so for mass it's kg, right? And then for temperature, it's not degrees Celsius that we usually use. It's in Kelvin. Okay, so this one you must take note because most students tend to forget. They will think it's degrees Celsius because we use it so often, right? But no, it's in Kelvin. Okay, then length is in meters. So this, at least the first three you must know. All right, first three you must know. Then you have current, amperes, time in seconds. That's all. So for mass, to measure it, you will use electronic balance or beam balance. Okay, and then for volume, you have quite a few different measurements. The tools, you have things like measuring cylinder, the most common one that you see, right? Then next time when you go upper sec, you will get to use the pipette, the burettes. They are more precise. Yeah. Okay, then what if you have irregular objects? How do you measure the volume? Right, you will use displacement method. Okay, displacement means you're displacing the water. And take note of the water level, it must be right at the opening, at the spout. So that whatever volume that overflows, it is the volume of the rock. Okay? Yeah. So that's that. Then just take note for measuring cylinder, how to read the bottom of the meniscus. Okay, the bottom means the bottom of the curve lah. Right? Okay. Then of course we always read at eye level to prevent or reduce parallax error. Okay. Next. Okay, this one measure already, right? Density. Now, less dense compared to whatever liquid, it will float. More dense, it will sink. Right? So this is the only thing you need to remember besides the formula. Okay. Now, the next thing that is very important is this. Okay, put a star there. If I have a block, okay, and I tell you the density 10 grams per cm cube. The density equals to this. What happens if I cut it in half? What happens to its density now for both the half? Anyone knows? each half would be, the density would be 5. Who says 5? Raise your hand. Okay, a few. Who says 10? Okay, a few more people. Who says 2? I don't know where you're going to get 2 from anyway. Okay, the answer is 10, 10. Why? Go back to the formula, the broken heart. If I halve the block, I will halve the mass and I halve the volume also. Cancels out. You end up with the same density. Okay? So as long as you are the same material, as long as you're the same material, you're the same block, made of the same things, your density will be the same. No matter how you chop it up. You can chop it into 3s, it will still be the same. Understand? Okay. Next, done with the first chapter. Very simple, right? Just physical properties. Next one, we're looking at the chemical part. Okay, so this is where it gets a little bit more content heavy. Okay, so that's why we have this flow chart to help you visualize. Now, for matter, we will categorize them into pure and impure. Okay, pure substances, you have the elements, you have the compounds. They are considered pure. Then the only impure one is your mixtures. Okay, all right. So elements, we go through the definitions first. Okay, I'll get to these 2 things later on. Elements, pure substance that cannot be broken down. It's the simplest form already. Okay? Yeah, simplest form. So if you guys play Pokemon, it is the first level. Haven't evolved yet. Okay? You cannot make it simpler anymore. Can? Okay, so classification of elements, right? You can do it by the state, solid, liquid, gaseous state. Right? Classify as metals and non-metals. Do you guys know how to tell? From the periodic table. Everything, okay, if you look at the periodic table, right, let me show you. How do you tell? You take from boron, you do a zigzag line all the way down. Everything on this side of the zigzag line is non-metals. Everything on the left-hand side would be metals. Okay, so just look for the zigzag line in your periodic table. Now, whatever you see in this periodic table, right, by the way, they are all elements. That's why it's called periodic table of elements. Everything you see here is element. And all of them have a unique atomic or proton number. Okay? So each element has a unique proton number. Okay? All right. Done with the classification. Now the next thing you need to know is how are they arranged? Why are they in like these rows and columns? Okay? So groups is the vertical down. Okay, my periodic table is the old periodic table lah. Yours will be 1, 2, all the way to 18. 0, yeah, 18. So, this here on top is the group number. Okay, so whatever you see is the group number, and all of them down here considered belong to group 1. Okay, so you're looking at vertically down, whereas periods is across. Okay, so group will be down the group, period will be across the period, left to right. So where will it be? Here. This one. Use a different color, okay? Blue color. This is across. That is one period. Understand? Okay, so you guys should know your horizontal and vertical, right? Okay. Then what they're saying that is that everybody in that same row down, their group, right? They will undergo similar chemical reactions. Similar. And the cool thing about the group number is it will tell you the number of valence. You guys know what is valence? The outermost electrons. How many? If you are in group 1, you have one outermost electron. If you are in group 2, you have 2. And then for non-metals, you look at the number behind. If you're group 14, you don't have 14 valence, you have 4 outside. Group 15 is 5. Okay, so for non-metals, you look for the second number. Okay, so this is shortcut method. Shortcut to finding number of valence. Let's say you don't want to do electronic configuration. For example, right, let me show you. You look at oxygen. It has 8 protons, which is equals to 8 electrons. Proton-electron number should be the same. Then from there, 8 electrons, if you were to write out the electronic configuration, what would it be? 2 points? 2 points? Y'all know, right? The configuration is what? Y'all learned it? 2.6, right? And where is oxygen? It will be found in group 16 because it is non-metal. Okay, and then you just follow the last number. So that's for the group number. For the period number, it also tells you the shortcut, which is number of electron shells. How many of the circles do you have to draw? If you're in period 3, you will need 3 of the circles when you draw the atom. Okay? Yeah. So done with that. How do you also tell, based on the diagram, whether it is element or not? Okay, so for example, they have either, they're only made up of one type of atom, either by itself or joined to the same type, right? But the color is the same. In one box, you only see one color. You don't have a mix. That's what makes it pure, okay? One type of atom for element. Then for compounds, you have 2 or more different types of atoms chemically combined. Chemically joined means they reacted in a chemical reaction, causing them to combine. For example, if you look here, you have sodium and chlorine. When they join together, right, they make a new product from the chemical reaction. Okay, it's totally new. So if you look at the diagram, you will see at least two different types joined together. That makes it a compound. Okay? The last one is mixtures. 2 or more substances again, but this time they are not chemically joined. They're just physically mixed. Okay, example like you make Milo. Let's say you want to make hot Milo, just put powder and water and just mix. That's all, right? There's no chemical reaction. It doesn't become something new at the end. So yeah, that is physical. Okay? And for physical, when you're physically combining them, you can physically separate also. So your hot Milo, after you mix it up, can you still separate it? You can. You just heat it up. Let the water evaporate. You'll get back the powder. Okay? So if you physically combine, you can physically separate also. Okay? So you have a few examples that you need to know would be things like seawater and air. they are mixtures of a lot of different gases. For example, in air, you have things like oxygen, nitrogen, right? You have carbon dioxide also, right? So a lot of mixtures of different gases just hanging around together. They're not reacting, they're just mixing, okay? Like you guys in the classroom, just mixing together, right? You're not joined together, no. Okay, so this is a mixture. Another common example would be your salt and sugar solution is like your Milo. You put it in, you dissolve, it is just a mixture. Okay? So how do they look like? Mixtures look slightly more complicated, right? You have 1, 2, 3 different types of things just hanging around. These two are the same things lah. Okay? So physically mixed together. Let me see. Okay, then the differences. This one I mentioned, right? If you physically mix, then you will just physically separate. If you chemically combine, you will need chemical methods to separate. Okay, chemical methods to separate. So, example, you need to know two of them. One is by heat. What is it called? Anyone remembers? You heat and then it breaks down. Okay, so we're looking at thermal means heat, right? And then breaking down, decompose. Thermal decomposition. Okay, that's the first method. Second method, okay, so this one is heat and it breaks down. Second method is when you use electricity and it breaks down. Electrolysis. So these two are the chemical methods that you need to know to break down a compound, right? Whereas for mixtures is physical methods. Okay, like just now I mentioned, evaporate the water away. That is a physical method. Okay, next thing you need to know is that for pure substances, melting boiling point is fixed. Pure is fixed. Okay, so when you look at the heating curve, right, from solid, it will melt at a fixed temperature. And then once you finish melting, then it will increase back up. Fixed melting point, fixed boiling point. That's how you know something is pure. If the question in exam asks you, how do you tell if this substance is pure? Just heat it and see if its melting point is fixed. Melting and boiling point is fixed. Okay? Then for mixtures, we say, oh, it has a range. It melts over a range. Because inside you have, let's say, 3 different things, right? And each of them have different melting points. So they will melt according to who is lowest first, and so on. So it comes in a range, right? Composition, okay. Example, what do they mean by fixed proportion? If you look at, let's say, glucose, sugar, glucose, C6H12O6, it's very specific. You have 6 carbon, 12 hydrogen, 6 oxygen. It's a fixed number. Okay, fixed number. Your table salt, sodium chloride, the one that you eat, table salt, also fixed number, 1:1 ratio. That's what they mean by fixed. Okay? Variable proportion, your Milo, you want to make it diluted, you want to make it super concentrated, up to how much you add in, right? So that is variable. There is no fixed amount. Okay. And then the last one you need to know is that for compounds, they no longer behave the same as the elements that they are made up of. Okay, example. To make water, you need hydrogen, oxygen. These two, for example, are gases. Okay, then your water is in liquid state. So, the water is a compound because it's made up of 1 and 2 different elements joined. So this compound no longer behaves the same way as its elements. That's why we say it is different from the constituent element that it is made up of. Okay? So what you get from this compound is totally new substance. It behaves like itself. Okay? On its own. Whereas for your Milo and your water, or let's say salt and water. You know that salt is salty. And then water is just water. When you mix it together, does the salt become something else? No. So your salt plus water, right? At the end of the day, you get the salt water. It is still the same property as what it's made up of. Okay? So that's that. You don't make anything new, basically. Moving on. Okay. Solutions and suspensions. You all know the difference? Okay, the first one is, this one is very uniform in the color, in everything. So when you look at it, like let's say salt water again. Salt water, when you look at it, right, it's uniform. There is no like, you don't see specks of salt just hanging around. No. Okay, it's uniform, fully dissolved, right? As long as it can dissolve, we call it a solution. Okay, and the solid that you dissolve will be called the solute. Okay, so it sounds the same. Solid, solute, that is the one that dissolves in the solution, okay, in that solvent. This solvent could be water, could be alcohol, right? So you must know the difference between solute and solvent. Okay, they will ask you to identify. And if let's say your solute does not dissolve, then this whole thing becomes a suspension. Like sand and water. The sand doesn't dissolve. That is a suspension. And most of the time when you look at suspension, it's very murky, very cloudy, okay? And then if you leave it to stand, you will see them settling to the bottom. Right? All the sand will just all settle and sediment onto the bottom of the test tube. Okay? So let's say you have sand and water. When you do filtration, you filter out. You will be able to collect a residue. Okay, so the residue, right, is collected here. The solids. This solids here that is trapped at the filter paper is called the residue. This one you also must know, okay? And then at the bottom, where the liquid flows through, that is the filtrate. But you will only get a residue if you use suspension and filter. If it's a solution, there's no solids for you to filter out because everything is dissolved. Like salt and water, you pour into the filter funnel, everything will just flow in, right? So for solutions, you won't get any residue. Nothing will be trapped. Okay, they will all flow through. Yeah. Okay, so this one I mentioned already, sedimentation, right? And then how it looks murky, right? Cloudy, doesn't mix well. And the last one is just to show you, right, some examples of what solutions look like. Okay, they are mixed. How do I call it? For example, right, you'll see here, they are like equally mixed. You don't see like all the solutes all hanging out at one spot. No, okay? They're uniform throughout the whole entire solution. Whereas for suspensions, you will see them hanging out at the bottom. Okay, the sedimentation. So the same thing goes for your air. You don't have oxygen just at one corner. No. Okay, they're all uniformly mixed. All right. Next one is solubility. Okay, we're almost done with this second topic. Solubility is how much you can dissolve, how much solute can dissolve in a specific volume of the solvent at a given temperature. Okay, so the volume and the temperature matters. These two things will affect the solubility. Okay, and of course, what type of solute? Are you using sand? Are you using salt? Are you using sugar? The solute will determine whether it will even dissolve. Okay, and temperature as well. You want to make Milo dissolve faster or dissolve more, then you use hot water, right? So temperature will affect. Okay, and then are you using water, are you using alcohol? That will affect solubility as well. Now, these two things would be different, although they sound the same. The second one is talking about rate. Rate is always how fast. How fast are you dissolving it? Right, when you make Milo, you just keep stirring, right? So the stirring will make it dissolve faster. Temperature also will make it dissolve faster. Particle size, instead of using 1 cube or lumps, you're using powders, right? Why? You are increasing surface area. More surface area in contact with the solvent, it will dissolve faster. Okay? What if it dissolves a bit? What is a bit? That means it is soluble, just not very soluble. So how do you make it more soluble? You can increase the temperature. Okay? Yeah. Last one. Ray model. Anybody struggling with light? Difficult a little bit? Okay, so I'm going to tell you a few methods later on how to draw your ray diagrams. Okay, we look at reflection first. Most importantly is I equals to R, you must know, right? Okay, what do they mean by incident ray, reflected ray, all of this point of incidence lie on the same plane? Means, example, if you look at this table, right? Okay, the incident ray hits, reflects off, all these things lie on the same plane here. It hits and reflects off on the same plane. This table is one plane, which is the mirror. Okay, so you just imagine there's like a whiteboard behind it. They all lie on the whiteboard. They are on the whiteboard. Okay, that is the plane. Anyway, not important. The most important is you must know this. I equals to R. Where is the I? It's always with respect to the normal. The ray and the normal in between, what is the angle? That is I. It is not with the mirror. You understand? Not with the mirror. I want the angle between the rays and the normal. That's why they draw the normal out for you. And if the question didn't draw the normal, you must draw your own normal. Understand? Okay. Next, regular versus diffuse. When you have a smooth surface, they reflect nicely at the same angles. That's how you get a clear image. Okay, and if it's rough, like the walls or whatever, then you won't get a clear image. You won't get a clear reflection. Okay, so they call it diffuse reflection, and you can tell they all reflect in everywhere, every other angle. Okay, but one thing does not change. The I and R does not change. I is always equals to R. Okay? Next one, how to draw ray diagram. Okay, I have this girl over here, Irene. Okay, her name is Irene. Now, Irene is going to help us to draw our ray diagram. How? Step number 1, image. You always start off your ray diagram finding the image. Where is the image? Equidistance from the mirror. If this is 2 cm, this must be 2 cm from the mirror as well. Perpendicular distance, okay? Perpendicular distance from the mirror. Once you find your image, dotted line. Because everything in your mirror is virtual. It's not real. So dotted line. Okay, take note of that. Right, you see in the diagram also everything inside the mirror is dotted. Done with the image, you will start with your reflected ray. Because that's what you see. You're looking at the image inside the mirror. So from the image, okay, you just pick one point on the image, you draw to the eyes. Right? So you draw from here, dotted line from the mirror, right? Dotted line. Once you come out of the mirror is bold line. And don't forget the direction going into the eye so that you can see. Okay, so that is the reflected ray. Next one, join it to the incident ray. From the actual object, you join to the point, it touches the mirror. So incident ray starts from the object to the point where it touched the mirror. Bold line because it's outside and the direction is towards the mirror. Okay. Can't see the table. What table are you talking about? You should be able to see in your own worksheet. Yeah. Because I have to post it there, that's why it's hidden. Last one is the normal. Okay, the normal is, okay, it's not in your diagram. The normal is right at the point of incidence, perpendicular, straight line. That is the normal. Okay, so why am I drawing in the normal? Just in case the question asks you to find I equals to R. Right? So at least you know where the normal is. Alright, so the next time or later on when you look at the practice questions and you need to draw a ray diagram, you will use Irene. Okay? Now, the images that you form. Okay, the images that you form. So, ink. Right? What are the properties of these images? So, remember it as this. Alright? First one, your image is laterally inverted. Means the left and the right is switched. Okay? Next one, the image and object is the same size. That means the triangle that you draw, right, cannot be bigger. Must be exactly the same. You look in the mirror, you're not bigger or smaller as well, right? Same size. And we also mentioned inside the mirror is virtual. It's not real, right? Your reflection is not real. It's a virtual image. And when you draw the construction line, we said that must be equidistant from mirror. If you're 2 cm away, the object, your reflection is also 2 cm away. Last one is upright, right? You look in the mirror, you're not upside down. Okay, so these are the ways to remember all the different steps and properties. Can? Okay, give you guys a bit more time to write it down. Okay. Next one is convex versus concave. Concave means it caves in. So look like this. Okay, so you're looking here. The mirror is inside here. So where do you usually see this kind of mirror? In things like your dental mirror, right? For your dentist to see inside, and it's magnified to see better, right? For small objects. Then you also have convex, which is opposite. It is like protruding out. So if you look at, like, let's say the roadsides, you will see those road mirrors, right? The blind spot mirrors, those at the side, or you go to convenience store, you look at the corners, usually they have one rounded mirror there, right? That is the convex mirror, right? Convex mirror, you're looking here, and what reflects is everything. You can see that it has a wide range, right? You can look at a wide field of vision. You can see a lot of things at one go. That's why they put at the stop, so that they can see if there's any suspicious person throughout the whole entire place, right? But the only downside is that, yes, you can see a lot, but they're all very small. Okay, so we say that it's diminished or smaller. The image that you see is smaller, not that the person is smaller, right? It's the image. Last part would be on refraction, okay? Refraction. Um, all right. So for refraction, right, there is one thing that I like to use. Fast. How does the light bend? Okay, we are looking at bending of light. Bending of light. We know that light travels in a straight line. This is what you learn in primary school, correct? But when you are going into different mediums, different materials, the light will bend differently. Okay, it no longer travels in that straight line. So how does it bend? Okay, when you look at optical density, if something is more optically dense, you think of it, dense means it's very packed. For example, you look at shopping mall. If you go to shopping mall, it's so dense, it's so packed. Can you move very fast when it's very packed? No, right? More optically dense means you move slower. Same for your light. If it's going into a crowded shopping mall that is more optically dense, your light will slow down. Slow, and it will bend towards the normal. Okay, bend towards the normal. Then on the other hand, if you're less optically dense, you can move faster and away. Bending away from the normal. Okay, done copying this. So you get the idea, just think about the shopping mall as always. Okay, and then think about this fast rule. Most of you don't learn this, right? Sin I over sin I over sin R? No, right? Okay, then I'm just gonna skip, okay? Skip to the diagram. Okay, so this is the slow and towards. This is the fast and away, right? What do I mean by towards? If your light were to travel in a straight line, it would have looked like this. But no, it bent closer towards the normal. That's what we're trying to say. All right. Same for here. If it were to be traveling in a straight line, but no, it's bending far away from the normal. Can? Ray diagram, the same thing, use Irene. Then the only thing you need to take note of is for refraction, the image is always above the actual object. If you're looking down, you will see the fish slightly higher. It appears to be higher. but actually it is not. Okay, so the common question is they will ask you, oh, why is it dangerous for, let's say, someone to look into the pool and decides that it is safe to jump in? Okay, so it's dangerous because what you're perceiving, what you're looking at is not as deep, but actually it's very deep. Okay, so that's why it's dangerous. And then the idea is the same. You draw the image, first step already, right, Irene? Then the second step is to draw your refracted ray, which is from the image straight into the eye. But now there's no mirror. This refracted one, right, from the image is not real, it's virtual. But the moment it comes out of the medium, that is the ray that you actually see. But where did it bend from? At this point, the incident ray is here. From that point to the actual object, that is the incident ray. Okay, and the last one is just normal. Then from that point, you just perpendicular down. Okay, that's the normal. Okay. Anyway, for diagrams, you always use pencil and ruler, right? For any diagram. And yeah. Okay, so answering technique, I'll just go through very briefly. First, you must tell me what is the optical density. Secondly, tell me the speed. Is it traveling faster or slower, right? And then the last one is tell me bending away or towards. So the last two will be the fast rule, right? The first one is just to tell me, is this shopping mall crowded or not? Okay, we're almost done. This part is just dispersion, right? No choice, you just go and memorize. Red color is the fastest and reflects the least. So if you're moving very fast, you have no time to bend. Okay, if you're moving very slowly, then you can bend even more. Okay, so it bends the least, that's why it's found at the top. Okay, and then for violet, found at the bottom, basically your rainbow colors. Your white light is made of the rainbow colors, right? When it's going through a different medium, it's bending differently. Every color bends slightly differently, so you see the rainbow color instead. Okay, so you just memorize one, then the opposite color of the rainbow will be the slowest and refracts the most. Now, this is the same here, right? If you put a second prism and you invert it, you will combine back all the rainbow colors back into one white light. Okay? So it refracts again back and combines. That's all. Last one is EM, but I don't think... Do you guys learn this? EM radiation? Okay, I'll just go through briefly. Infrared is the thermal imaging. It's the one where during COVID, right, you go to the shopping mall and then they have this like scanner right at the front. You guys remember that? Right? Then you can see like, oh, you like, do you look like orangey or red or whatever? So that's thermal imaging. Okay? But you can't see the light. You don't see any light that's coming out because it's not visible. Right? But it is there. There is the radiation there. Okay, and then you have UV light from the sun, etc. It helps to kill bacteria, right? That's why it's used in your new water to kill bacteria so that your drinking water is safe lah. Yeah. But the harmful effect is that it will damage your DNA in your cells. So damage your skin and your eyes, right? Can lead to skin cancer as well. The last one is the visible light. Visible means you can see. It's the light that we can see. Okay, it's used for photosynthesis, etc. Harmful effects like pollution for your nocturnal animals. Okay, it affects their vision. Okay, so that's that. Okay, done. Now, what I want you guys to do is to take some time and try the MCQ. Okay, there's 11 MCQ questions. Let's take about, you should be done within 20 minutes. Okay, so you try on your own. Done already, is it? Okay. So I'm done. Oh wait, before that, I need to mark attendance. You just go down the row, okay? Your name? Your name. I need to mark attendance. Sorry? Jester. Chester. C, is it? CH. Don't see your name anywhere. Okay, okay, I see it. Chester. Next. How do you spell? ANEH. Let's see. Mm, Let me just add it in. Okay, next. Damien. Next. How do you spell? EYAN. Ian, okay. Next. Caden. KA or CA? Caden. Okay, next. B. Ben. How do you spell? Matt. Okay, yes. Found it. Next. Sing with a G. XIN. N. Okay, next. NRAEE. Okay. Next, behind. Sarah. Okay, next. GAY. Okay, next. Haley. Yep. Next. How do you spell? Okay, found it. Next. Third. Megan. With the E at the back. Next. Joelle. Next. Do you spell? Ping. Okay, Ting next. Sophia. Sophia. Sophia Ng. Okay. Next. Behind. Jaden. Jaden Lim. Next. Samantha. Next. CA. CA. Okay, next. Janice. Janice. But the name is Charlene. Janice Ng, right? Oh, what's your name again? J-A.
I'm Charlene.
Janelle.
Charlene.
There's no more J-A already. Okay, let me just type it in. Jennison. Okay. Any more? Okay, no more. Okay, wait, those who are done, right? Those who did it beforehand, I'm gonna mark for you first. Yeah, which who else is done? Who else? Were you supposed to do this beforehand when you came to collect? Option 4 is the problem. Option 4 and 6. Hey, why got two blanks, Janice? Huh? You what? You skipped? Why? But exam you still have to write something, right? Hey. Then also, the rest of you have about 9 minutes. You look through the questions, right? And then later on, we will go through those that you guys need. 5 p.m. Where are we? Okay, we're on time. After we go through the MCQ, then we take a break. Okay? Then we come back and then we do the free response. Yeah, then we will play the booklet. And then we're done. MCQ only. Yes, MCQ only. Then I'll go through in about 5 minutes time. Okay, finish up as much as you can for those who are still trying. Hmm. Wait ah. Next. Maybe there's more, I don't know. What if we are done? If you're done, you just wait for a while. I'm gonna flash the answer in 1 minute's time. For those who are still trying, okay, you guys continue first. Online students, you guys mark your work. This is the answer key. And then you can type in a chat, right? Let me know which questions you need to go through. Okay, and those that are here physically, you just tell me which questions you're not sure, you don't know how to do, don't understand. Okay, so what questions should we go through? Those that I've already marked and you've checked your answers. You're not sure at all. Why is the answer like this? Okay, so the common ones I saw was question 4 and 6. Any other questions? 7 as well. Anything else? 10. 1, 7, 8, 10. Question 1. 7, 8, and 10. Any other question? 8 also, yeah, okay. Okay, I'm gonna start in about 30 seconds time. Question 3, okay, question 3. Okay, shall we? Let's quickly go through them. We can take a break. First one, the metal is used, tungsten, to make the filament in the bulb, right? Some physical properties are listed below, right? So why is it used as the filament in your bulb? So, of course, it shouldn't melt, right? The metal that you're using inside is a solid. So obviously you can't have it melting, but there are times where you have the fuse bulb where it overheats. That's why it melts. Okay, but by right, it should have a high enough melting point so that it doesn't always melt and fuse. Okay, so number 1 is important. Boiling point, it probably won't reach that high anyway, right? In the bulb, most likely, we don't care about the boiling point since we are starting off as solid. Last point is it must be a good conductor of electricity so that you can have a closed circuit. That's question 1. Next one is question 3. Okay, they're asking for the final level. We're looking at volume. You should know how to calculate volume, right, of cuboid. Just base area times height. Correct? This is the volume of the cuboid. You start off here. There's only 5 basically readings. So each one will be 2 units. Yeah. So at the bottom of the meniscus, we have the reading of 38 cm cube. 38 plus here 24, you will get the final volume. 62. Okay, so it's either your calculation somewhere is wrong or you read the meniscus wrongly. Okay, so there's only these 2 possible answers, misconceptions that I can think of for this kind of questions. Next, question 4. Non-metals versus metals. We mentioned, right, the zigzag line. This one you should not be getting it wrong in the first place. You're left with option A and B. Elements in the same period. Period is down or across? Across. So same period is P and Q or no more already. That's the only one we have. Option A. Left to right, be found in the same row. Okay, next one, question 6. 5 okay, right, everybody? Question 6. Now, elements, compound, and mixture. Right, we talk about a few common mixtures like air, like sea, water. Right, so the moment you see all of this is a mixture. What about carbon dioxide? Carbon dioxide, di means two. Two oxygen joined together. So it looks like this. One carbon with two oxygen. Okay, like the Mickey Mouse ears. When you have two joined together with a carbon, this makes it a compound. Two different types, chemically combined. And gold by itself is just an element. It exists in the periodic table by itself. Next, air, we say is mixture already. Water also has this Mickey Mouse ears configuration. Oxygen in the middle with H at the side. H2O. So it's a compound. What about salt? The table salt that we eat looks like this. It's called sodium chloride. Sodium and chlorine joined together. Compound. No element in option B, so out. Next, element, element, mixture, element, element, compound. Okay, so just like that. Option A is our answer. Next is question 7. Mixture of iron and sulfur. And then we have a compound. Okay, so you see two different things. They want you to compare, right? If it's a mixture, yes, there is no chemical reaction, right? Whereas for iron 2 sulfate, it is a chemical reaction. You form something completely new, a new product. Okay, so statement 1 is correct. Next, statement 2. It does not have the properties of iron and sulfur, right? So mixtures, this is wrong. Because like your salt and water, you mix together, it is still salt and water. Okay, so it should have the properties of both elements. Then if it's a new product, then it shouldn't. So it's opposite. You should swap it around. Okay, if you swap it around, then the statements are correct. The last one, the ratio can vary. Yes, how many iron you want, how much sulfur you want to put, you can change, but compound is fixed. Okay, the ratio is always the same. Question 8. This kind of question you just draw out. Okay, if you can't visualize it, then just draw it out. We have our mirror here. Okay, and the patient is X distance away from the mirror, right? I don't know where he is, but we just use algebra to solve. Then behind him, right? Behind the patient, 25 cm away is the cart. So we have the cart 25 cm away, behind him. Now, the distance between him and the image of the cart is 385. Between him and the image of the cart is all the way here. 2x plus 25 equals to 385. Solve for x. Okay. So 2x equals to 360. How do I know what is the distance of all of this? Is equal distance from the mirror, right? Last one is question 10. Yeah, move on. Question 10. Not caused by the refraction. If you see an image in the water, that is just like, it's like a mirror. It's a reflection, not refraction. Reflection. Okay, if you see a clear image, means it is regular reflection. Okay. All right, let's take a 5 minutes break. So if you need to go toilet, it's right over here. And the snacks are at the shelf at the back. Help yourselves. So all the answers, okay? For teaching. These are the answers. Okay, let me mark attendance for our online student. Okay, 5 seconds left. Right. Let's move on to the free response. Okay, let's look at question 12. One material is able to leave a scratch on the other, right? So what are we testing for? What's the physical property? What's the physical property? That you can scratch. Hardness, right? Scratch test. Testing for hardness. If you can leave a scratch, we will put a tick. If not, it's a cross. So look at the table and DIY, go and arrange in order of increasing hardness. It shouldn't be too difficult, right? So if you look at R, it can scratch both of the other material. So it must have been the hardest one. Followed by P that can scratch Q, and then Q can't do anything to the others. Right? So you should have gotten this as your answer. Next. Electric cable attached to an electrical water dispenser. State two properties of the copper wire. Okay, let me just go down the name list. Gil, two properties. The copper wire should have, yeah, wires must do what? Wait, let her try. Like this wire, right? My computer is charging. This wire must be able to conduct electricity. That's one, right? What else? What else can it have? Next person, Haley. If you all sign up together, then your names will be next to each other. Haley, besides electrical conductivity, just what do you think? Okay, it's okay to be wrong. It's fine. We're just trying. So you think about all the different physical properties that we've learned. Hardness, flexibility, blah, 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 melting point, density, all of that. Just choose one that you think is suitable for a copper wire. So, Haley, you look at my wire, look at this. It's all coiled up. Exactly. Okay? Flexible and a good electrical conductor. Okay? Yep, Charlene, flexible. Can I say it's a poor conductor of heat? Um, Poor conductor of heat is not related to its use per se, right? What the heat does not have anything to do with its usage as an electrical conductor. So that it does not fuse. The fusing is the melting. Then that will be melting point. Yeah, not thermal conductivity. Part C, protect users from getting an electrical shock. Copper wire must not be exposed. Paper, you use it to wrap your wires. Does it make sense? Right? Let's Next person we have is Janabel. Why paper is not suitable? Exactly. Okay, easily torn or it's not waterproof. You can say that also, right? So exposing the copper wire. So that's why it's not suitable. Then what is usually used for our casing, right? Plastic or rubber. Just choose one. Both are accepted. Okay. Moving on. Question 13. Okay, can you guys go and do the calculations? Show your working. Those who have not done it yet. Yeah. From your explanation in C, I suggest the material. No, you don't have to choose from there. Because you won't be able to tell, right? PQR is just showing you the hardness, but it doesn't tell you whether it could be a metal, we don't know. Yeah, so suggest. Usually suggest, just provide logical answer. Broader explanation for 12A. RPQ. Okay, Andre. Let me explain that again. Okay, the rest of you continue with 13. Okay, for Andre, part A, right? They're asking for hardness. Means can you leave a scratch or not? The hardest one, right? So it's least to most. The hardest one must be able to scratch everything else. So it's R. It can scratch both P and Q. And then you chose, that means your order is wrong lah, actually. It's just the order that is wrong. You understand? The sequence is that R is the hardest one. So R should be at the back because I want increasing hardness from least to most. Then the one that can't scratch anything at all would be Q. So that's why the answer looks like that. Okay? Alright, I assume you guys, not yet, okay? Try first. I'm not gonna show the answer until you guys try. Two marks. Total volume. Okay, let's go through part A. You will still, density question, we always use the broken heart, remember? Right? Given the mass, look at carbon first, yeah? Given the mass and the density, can you find the volume? Yes, just rearrange, right? So volume of carbon equals to mass divided by its density. Okay, that's the volume of carbon. Then we want to find the same thing, volume of iron. You will take mass divided by its density. So these two things added up would be your total volume. Okay, then you just key into your calculator, leave your answers in 3SF. Final answer 3SF. Okay, and she have gotten 1260 EMQ. Don't forget your units. One two five five point oh five. 1255.05. Then you will round to 3SF. If you don't know what is 3SF, you look at the third number, third significant number figure. Then you look at this next to it. More than 5 and above, you round up. CMQ. Right? Then we will always, the moment you round it, you always have to show, is it 3SF? If the answer asks for 2SF, then you round to 2SF. Okay? Next, calculate the density of the malt still. So now, you combine all these things together to give you the malt still. You know the total volume. Now they want the density of the malt still with all of this combined. So you will take total, so the density equals to total mass divided by total volume. Total volume you calculated, and you're supposed to use the 5SF number because it's more accurate. Okay, so workings, we always use the 5SF one. The more decimal places there are, the more accurate it would be. Total mass is how much? You just take this, add with 30, right? So that's like what, 980? 98. Yeah. Right? I'm not tripping, right? Yeah. Divide by total volume 1255.0. 1, 2, 3, 4, 5. Yeah, that's 5SF already. Then just key into your calculator. 1, 2, 5, 5. 7.807. What's the units? It's given here, grams per cm cube. But that's 5SF. Final answer, round to 3SF. Look at the third significant figure and the one next to it, more than 5, 7.81, 3SF. Okay, next. Knowing that this malt still has a density of 7.81, is it going to float or sink in water, Kaden? Sink, yeah, because it is what? Denser, exactly. Okay, simple, right? The explanation. Denser, it will sink. Less dense, float. Then what if it's suspended? Not sink, not float. Right? Next person we have. Met. Not sink, not float. The volume. Can you tell what is the volume? No, right? You don't have any information about the volume. But what you can infer is that if it doesn't sink, it is not denser. And if it doesn't float, and if it doesn't float, it is not less dense. So if it's suspended, it must be density is the same. Density is the same as the liquid. That's why it's in the middle. Okay, so it is how much? This solution will have the same density as your malt still lah, which is 7.81 grams per cm cube. Okay, so write it down at the side. Suspended in the solution equals to the same density. That's why it doesn't sink nor float. Exact same? Yeah, because if it's slightly more, it will sink already. Right? Do you? You float in water because your lungs have air, ma? But your density itself might not be that, right? But we do float on Dead Sea though. Because Dead Sea, right? The salt content is very high. So the mass, right, is a lot greater. Therefore, its density is also very high. So compared to us, when we lie down on the Dead Sea, right, our density is lower. So we float on Dead Sea. Okay? So you are very buoyant on it. Moving on. Question 14 is only for IP students, so we will skip. Right, it's just conversions. Question 15. Yeah, let me see how much more we have. Okay. Question 15. Have a cup of tea bag placed into water for 20 minutes, and I see this. Explain if this mixture is solution or suspension. Ian. Suspension, how do you tell? Particles settled at the bottom. Yep. So it's a suspension and particles settle at the bottom. It's like sand and water, essentially. And they settle to the bottom because they don't dissolve. They cannot dissolve. That's why they just hang around and then slowly, due to gravity, they're found at the bottom. Insoluble in water. Yeah. Why the water turns brown? That means something else in the tea bag must have been able to dissolve. Dissolve and diffuse and everything turns brown. But then in your tea bag, then maybe let's say the tea leaves, right? It can't dissolve in water. So that's why they will all just settle down to the bottom. And then for suspensions, right? We can confirm and verify if it really is a suspension, like sand and water. If you Next person would be Ian, done already. Police. What can we do to the suspension? Filter, and what would you see on the filter paper? Residue. Yep. So for suspensions, you will see residue, but solutions, you won't see any residue. That's how you confirm. Next, table sugar. It has this chemical formula. Explain if it's EC or M. Next person, Jaden. Where's Jaden? Jaden? Jaden, EC or M? You think? Not sure. Not sure. Okay, who says it's element? What? Compound? A few. Mixture? Nobody. Then the rest of you? Don't know. Look at this. They give you chemical formula and it's in fixed numbers. Fixed numbers means it's fixed composition. And you have three different elements. You have C, H, and O, which is carbon, hydrogen, oxygen, joined together, right? Combined together in this very fixed ratio. Two or more elements joined. And in fixed composition, it must be a compound. Okay, so that's how you analyze question. Okay, it's a compound. So like I said, it contains different elements chemically combined. In this case, 3. Next. Yeah. So since it's only 2 marks, you can choose either one to write. So 1 mark is for stating it's a compound. The second mark, you can tell me it has a fixed composition by mass. Either that or 3 elements chemically combined. Okay, so the word chemically is important. Because if you just say combine, it could mean physically, but that's not true. Next, question 16. Forming a mixture, few drops of essential oil dissolved in ethanol. So usually when you see this end with OL, right, they are alcohols. So it's a type of, is it solvent or solute? Cynthia, no, Cynthia is not here. Janice. Alcohol, is it solvent or solute? The solvent. So it's a type of solvent like water. Okay. So essential oil dissolved at a specific temperature, room temperature, producing perfume. Right, so you know what is the solvent already, which is the ethanol. what is the solute that you put inside to dissolve? Quite simple, right? Intuitive. You're putting this inside to dissolve. So essential oil is your solute. So take note, this solute doesn't necessarily have to always be solid state. Okay, in this case, we have the oil version. And what you get at the end of the day is what we call the solution. So what do we get? A perfume. That would be your solution. Now, let me ask you another question. This perfume, if I filter, will I get a residue? No, because it's solution. Everything is nicely dissolved already. Okay, good. Moving on. Part B. At a specific temperature and at 100 cm cube. So like I mentioned, for solubility, temperature and volume is important. Okay? At specific temperature and volume, we have two different salts. First one is copper 2 sulfate. Okay? If you guys don't know how copper 2 sulfate looks like, the solution is very nice. It's a uniform blue solution. Okay, it looks like this. Okay, it's uniform. You don't see any murky, whatever. The light can pass through fully. It is a solution. Okay, now this copper 2 sulfate solution, the solubility they tell you is for every 100 grams, 100 cm cube of water, I can dissolve this amount at 25 degrees Celsius. This is the maximum to dissolve, or that can dissolve. Maximum mass that can dissolve at this temperature, at this volume. Same for sodium chloride, 36 grams maximum. Okay? Based on the information, comment about the difference in their solubility. So after Janice is Sarah. Which is more soluble? Sorry? It's more soluble. Which one can dissolve more? Sodium chloride. Yeah. So if you can dissolve more, you are more soluble. Copper 2 sulfate. Or if you write the other way around, it's fine also. Copper 2 sulfate is less soluble, fine. Okay. Part 2. This is quite a common question. Part 2, they always like to ask you to find how much will not be able to dissolve. Okay, it's like Milo. You pour a lot of powder, right? Some of it cannot dissolve, right? So how much? So this is where the volume and temperature is important. At 25 degrees Celsius, for sodium chloride, right, we say we can only dissolve 36 grams, maximum 36. Then you pour in 50. Obviously, the remaining cannot dissolve. So that's what you want to find. Calculate the remaining mass that cannot dissolve. You just take 50 minus 36. That is your working. 14 grams remain undissolved. Now you get a suspension because these solids will settle to the bottom. Okay? Now, going further, what if the question gives you, instead of 100 cm cube, it gives you 200 cm cube and this 50 grams of sodium chloride? Then how do you tell? What is the maximum that can dissolve in this new volume? So if in 100 cm cube, I can dissolve 36, 200, you just times 2. So if I pour in 50 grams, will you have any residues? No, because 50 grams, all 50 can dissolve. Okay? All 50 grams will dissolve. So the volume is important. Yeah, at the same temperature. Only at the same temperature, then this will apply. If you switch up the temperature, right, the solubility will change also. That means if it's, let's say, 50 degrees Celsius, it will no longer be 36 anymore. Yeah, so we keep it constant. So the only thing you change, let's say volume you change. Yeah. But it's proportional. You increase times 2 the volume, the amount you can dissolve also times 2 is proportional. Okay, next. Part C. Identical sugar cubes were placed in beakers with varying temperatures. So you know temperature will affect the solubility. State and explain which beaker the sugar cube will dissolve the fastest. So we're looking at rate now. How fast? Which one will be the fastest? So we have 25, 50, and 80. Quite simple, right? This one, obviously, beaker C. Temperature is the highest, that's why. What else will affect the rate? Okay, let's have the next person. After Sarah is Ping Xuan. Yes, particle size and stirring. So to dissolve even faster, we can stir the mixture, right? And use so the particle size, are you referring to bigger or smaller? Smaller pieces of sugar. That's why a lot of the times the sugar you use are all in the small little forms, right? Not the cube, right? Not a block. Right? It's all the powdered sugar. What am I writing? Dissociating, sorry. I had 2 classes before this. My brain is fried. Smaller pieces of sugar. Okay, smaller pieces of sugar increase surface area so that it will dissolve faster. Moving on. Okay, move on. Question 17. State 2 properties of plane mirror. So images have all these properties. Just choose 2. Okay, go and fill it on your own. Okay, they're saying that if you put 2 mirrors together and then at an angle, you will be able to see multiple reflections. Okay, so that's just the context of the question. Part B, okay, once you're done with A, right, go ahead and try part B where you have to draw. Then you will use Irene, right, the girl. Use the 4 steps to get to your ray diagram. So part B is asking for you look at BI. BI is asking for image first. In mirror number 1, find the image and label it I1. So those who have done it, you check, did you label I1 for the image and show your construction line. So mirror 1 is here. What we always do is to find from the object perpendicular distance and also equidistant, right? If it's 2 cm to the mirror, it will be 2 cm away from the mirror. Label I1. The construction line is just the dotted line to show the equidistance. Okay, so blue color is step number 1. Image done. Second step is always to draw your reflected ray from the image straight into the eyes, dotted line inside. When you come out of the mirror, bold line with our arrow indicating the direction. Okay, step 1 and 2 done. Now, I just need you to complete the other 2 steps. This one is only rays only rays outside the mirror. Are look at the incident ray and the normal. Incident ray. Going into the back. Not big. The grey one is not the answer, okay, for part A. The grey one is for later on. So you are still missing the I and S. Where's your incident ray and where's the normal for mirror one? Why everybody like them now? Hello, log in please. Hello. Like, maybe give you all the tests. I have a group number 1, 2. Okay, the I. Guys, the that gray one, right, is not an incident ray, okay? I'm telling you. Incident ray is where the light come from the object. It must hit mirror 1 first. It has to hit mirror 1 and reflect out into your eyes. So wherever it hits the mirror is wherever your reflected ray comes from. This point. So it's from the object to this point where it hits the mirror and reflects into the eye. So the eye would be can I use a different color? Orange. The eye would be this. From this point where it hits the mirror, back, you draw backwards. Okay? And then reflects like this. The arrow is pointing up. Because it's going into the mirror and reflect back out. You understand? Then the normal would be perpendicular to this. Just put your ruler perpendicular. Okay, I don't know if your school needs normal or not. You just follow your school criteria. If don't need, then you can just forego the last step. Okay. So essentially, the blue, the pink, and the orange is your number one ray diagram for mirror one. Understand? You must know how to draw, okay? Because they will test. And ray diagrams usually worth a lot of marks. Alright. Okay, leave this here for those who need to copy. Then the gray one is for part 3. Right? At M2, you have another mirror. Then you need to find perpendicular distance and equal distance from the object. So again, construction line will be dotted line and then just show equidistance. Okay, right? You all learn in math, right? This symbol means equidistant. And then label I2, right? Like the question asked. Sometimes they will ask you to label as I prime, X prime, whatever. You just need to read the question. Okay? Done with that. Now we are at 18. And then we are almost done. Okay, can you guys now, those who have not tried or those who have tried, I want you guys to relook your answer using the fast rule. Look at how the ray bent, right? And tell me who is the more crowded shopping mall. Is it X or Y? Okay, go and figure it out yourself. Yeah. Look at how it bent. It's words or array. But you just don't need. You need to fill in the blanks also, right? You can just write the answers. The fast and bend away, or is it slow and bend? This body is great. What could it have been? But I really see that this is great and normal, very normal. So the art of it, right? diagram for the previous question. Is it this one, Christine? So, mean what? The red and what? The red and what? Or red. So you find here, right? Red and the normal. The red and the red. All right. Shall we? Okay. So this ray, if it were to be going straight, it would have looked like the dotted line one. But it in fact did not go straight. It bent towards where our normal is. So we're looking at fast and towards, slow and towards. Okay, slow means is the shopping mall crowded when you're walking very slow? Yeah, right. It's very dense, optically dense. So medium Y is causing the light to slow down and therefore bend towards the normal. Okay, so medium Y is the optically denser one. Speed of light decreased when traveling from X into Y. It slowed down, so it is optically denser. Okay, so just check your answer. Did you guys get this? Okay, so the answering is always which one is denser? Bend where, and then what happened to the speed? So these 3 points to get you the full marks. Next, I want to look at angle of incidence and refraction. Angle of incidence is always between the ray and the normal. So I want to find this. And you know that normal is always 90 degrees to the mirror. 90 minus 15, you get angle of incidence. Okay, 75 degrees. And then, if you guys learn from your math, okay, let me clear all of this. When you learn in math, right, when you see the x, these opposite angles are equivalent, right? So 15, 15. What I actually want to find is this ray. Okay, use a different color. I want this ray and the normal. I want this angle. Again, the normal is 90 degrees to the mirror. 90 minus 40 minus 15. You will get your R. Alright? I equals to 75, R equals to 35. Okay, so that's why the normal is very important. It's always with reference to the normal. Alright. Last part C, and then we're done. Okay, part C, right? Can you guys try first? Those who haven't tried it, I want you guys to draw again using Irene. This time we're looking at refraction. That means there is a bending of light and they want to see if you know how it bends. Those who have done it already, you just double check if you have all the irene in. One this, one red, and where's the image? Where's the eye? Irene must have eye. Yeah. How the fish is seated. It's not the fish passes. And then it means the insect will get. You want how the fish. Where's the image? Where's the eye? This is the real incident. This is the real. Where's the eye? Apa itu? From inside the water, the fish looks at the inside outside or the image. Right? So the radius runs in straight line, even though it's only not one ray, right? It's looking at ray. Got two coming up the one. Three, you see? I'm literally about to crash out. It's this is my 7th hour of class today. Sorry? Why do I what? You're right. Why? It's a very good question. We made bad choices every day. Where is my light? Where is my... Where did I write it? You see this? You see this? Hello? People? If your image is on the side, your whole diagram is wrong already. It has to be above the object. No matter in water or in air, as long as it's a refraction question, your image will always be above. Okay? So you go back to that archer fish, right? You look at it and like, okay, I'm looking at the insect, but what the fish is actually looking at is the image of the insect which is above. So this point over here is above the actual object. That is your eye. You must start off from the eye. You can't start off from the insect itself. Again, if you start from the insect, it's wrong. From the insect is what the fish is going to see, the image. Straight line to the eyes. But this is virtual. Image is virtual, right? That is not real. So we dotted line. But the moment it comes through the water, right, the line, through a different medium, this is where it becomes the real light ray that was refracted into the eyes. So done with the I and the R, we have the refracted ray. Now you're left with the incident ray coming from the object itself. That is where the real light ray is. From the object to this point where it hits the surface of the water, that is your eye. Arrow to the surface, and then you can see that slight bend into the water. Last one is the normal perpendicular to the boundary, 90 degrees, dotted line up. Then you check, did this ray bend towards the normal? Yes, because water is optically denser. Okay, and then I give you the answer for D already. This is how your light ray the diagram should look like. Okay, so go home, you will go and practice the Irene all over again. Okay, this is the kind of questions that honestly all my Sec 1 and Sec 2 struggle with. You just need to keep practicing and you'll get used to it. Okay, next. Okay, last question already. D. Describe and explain how the light ray from the insect travels when it goes from air into water. And you know that it bends towards, right? So we're looking at slow and towards means water, you're moving slower. It is very crowded. It is optically denser than air. You must use the word optically, okay? Like I said, if you just say denser, no. Okay, light is optically, right? You have to add that word just to be more specific. And then light travels. Again, the speed. Talk about the speed. Slower. Bend towards. You see the phrasing is very standard. It's same. Same as previous. Okay? And so before your exam, you just go back and practice whatever light questions, ray diagram questions you have, right? And then, of course, when you're drawing, you use pencil, right? Matt, right? If not, you draw wrongly, like how are you going to erase it? Okay, so in the exam, just bring your pencil, ruler, eraser, and calculator. And pen, of course. Okay, done with this. What else do we have? Nothing right here. Where the fish should aim. Yeah, lor. Where the fish should aim is just higher lah, which is at the image lor. No, what am I saying? Where it should aim, right? Because what it's seeing is here. So imagine if it aim for this X prime, the image, will it hit the insect? No, it should aim slightly lower. Yeah. Okay, aim slightly lower. Suggest where the fish should aim. Aim slightly lower. Okay, done with this, we will just quickly move on to the booklet. I don't know if it's gonna work, okay? So we'll just try. Okay, so take out your phones. The Wi-Fi is Wi-Fi. Okay, you look for Overmugged Wi-Fi, and then the password, small letters, exclamation mark. Okay, I'll lend you mine. Um, Let me just turn this on first so that which one should we do? Should we do crypto hack? Those who have played this before. Crypto? I want to change the time. Can I change the timing? Okay, nice. I can. Okay, we do about mm, I have 20 questions. 15, 13 minutes should be able to finish. Okay. Then you just scan the QR code or you enter the link. The game ID is what? The 573 is. Wow, wow, wow. Okay. What, how many people? I didn't know you can change this. This is the first time I see people changing this. The background. You need an account. Okay. My favorite character is the fox looking one. Let me see if anyone has it. Not here. It's the snow fox looking one. Okay, is everyone in yet? Wait, let me see the chat. Is luck based? No. Skill based, okay? If you get it wrong, then it's a skill issue. Okay, I mean crypto is kinda luck, but still, you must get it correct first, right? Okay, can I start? Is everyone in? Okay, I'm gonna start already, ah. Yeah, mine is this, the Megan's one. Oh, yeah, that snow fox looking one is good. Okay, instructions for those who have never played it before. Okay, you choose your password, you answer questions, and then you try to hack other people's password. Then you get the points. The highest points win. So if you're fast enough, right, the questions will repeat. Then you can just keep getting the right answers. So on your screen, you should be able to choose your password later on. Click into the photos if it's too small. Okay, later on. Hi, who is hi? Hello. Hi just took from India. Hi again. Who is this hi? Ah? Who is it? Ona. Who is this thief? Just kidding. This is the quietest book. Next time you should ask your teacher to play the cooking, the cafe one. That one is quite nice. I've heard it before. Like, 4,000. Yes, quite a few people getting the solubility one for. They're asking which factor affects solubility, not rate of solubility. Okay, it's different. Rate and the solubility itself is different. Right. This is for yourself to know whether you learned anything from this event. Anything at all. 2.1 million. Oops, got overtaken. Read the question start repeating because there's only 20 questions. And if you're tired of answering the same questions over and over again, you can we know we lost. 5 minutes left if you're still interested. If not, you can just chill. 80 million? That's crazy. 809 million? That's 3 minutes. Well, if this was real money, we have raised 38 billion, right? Janice being, oh no, now it's Tingshen. Tingshen being the main contributor to this 38, 57 billion now. Whoa, whoa, whoa. Calm down, calm down. It's just a game. It's not that serious, guys. You have still a few minutes to catch up. Hey, Xinhuan left already. Left the chat. Oh wait, no, she's back. Okay, 1 and 2, close game. By now, you shouldn't be getting the same answers wrong again. Okay? Because when the questions keep repeating, you should get the answer already. What? You keep what? Misclicking. Okay. That's fine. No pressure. Okay, 1 minute left. Afterwards, I will need you guys to do something else. Okay? 411 billion. Why is it negative? Why is my money negative? Well, 30 seconds left. All right. Final standing, Justin, Matt, and King Shen. Okay, good job, everybody. Now, done with the booklet, right? Final parts of today's workshop, right? If you would like to get a free foolscap pet, right? Would you guys leave a Google review? Could be anything to the Coven since you're here at Coven. So you just scan the QR code and then after you're done with the review, you just show me the confirmation page and then this is how the foolscap pet looks like. Okay, with Monkey, the mascot. Okay, so only for physical students, unfortunately. You want to do the review? You decide. That one. Yeah. All right. You know what? Not refreshing. Else done with the review? No one else? Okay, it's not only, but you know your password. What that? You can reach that, and then later on this here's larger. It's like the complete complex. So, oh, okay, I know. Here's larger. Okay, that's because you're magnifying from end to that, back out, there's long. So the bending and where are you at? Later you pass the phone behind. Okay, those who are done with this review, right? The next thing I need to just quickly go through is if you're interested to sign up, not really sign up, okay? It's just interest form. Okay, you can take a photo of the perks and then you go home and you just show your mommy or your daddy, right? You don't have to scan now, okay? Yeah, so basically what this early perk interest form is that you just indicate your name to log in the perks, right? Then you can decide and think whether you really want to sign up. If you don't want to sign up, it's fine. This interest form will just be another data in the system. But if you do want to sign up next time, let's say your mommy says okay, then you still have the perks locked in. So that is just that. Okay, Ken? So you just show your mommy this and then that's for next year lah, next year's classes. So now you're set 1. Set 2, these are the available classes. If you're interested to join, there's English, Math, and Science. Okay, so you just take a look on your own if you're interested in anything. Right? Okay, sure. Okay, if not done with this, right, you guys can start packing up already. Okay? If you have no other questions, then yeah, you can pack up and then you can leave. I lend you my laptop instead. I mean this one. Or is it because it's the education equipment? Let's try. Okay, if you're done packing up, you can leave already. Unless your parents are coming here to fetch you, then you wait here. Okay? If you're going home on your own, then okay, feel free. Bye. Okay, those online, you guys can leave too. Bye. Where? You just search overmarked. Coven. Move in. How do you add review? It's not signed in though. Huh. Done. And write a review. I need to write. Let's try something. Alright, I don't know why you're asking Mike. Yeah. Chưa có thả lại phone. Bắt phone nào. Yeah. Wait, I send you some. Okay, okay, forget it, forget it, forget it. You guys just take the postcard and go. Okay, okay, go, go, go. You never press anything, that's why you couldn't post, is it? Okay, okay, never mind, never mind. Yeah, lor. Okay, then you just write something. Where? Oh, what was the star again? Oh, how many? You have five lah. Okay, okay, bye. Bye bye. Throw away your rubbish, yeah. Is it your dad outside? Someone is outside waiting. He was looking for you. Okay, bye bye. Bye bye.